Question 8. So we have a scale drawing here of the points A and B with the north lines drawn in. We are told that point C is due south of A, so somewhere along this line will exist point C. We are also told that the bearing of C from B is 235 degrees. So what that means is if I draw in an angle of 235 degrees drawn clockwise from north, then somewhere along here is where C is going to be. So based on the two things I've said, it being south, we're going to be somewhere like that. Now the only way of you actually being able to do this question is to accurately draw that angle, where I may have deleted that angle of 235 degrees. Now 235 degrees is 180, which will represent this first 180 degrees, plus an angle of 55 degrees, which will make up the rest like so. So our line that we draw needs to be measured so that this here will be 55 degrees. We draw this accurately using a protractor. So if I set up my protractor like so, given the fact that we have 180 degrees taking us round to here, this would be our line. Therefore we'd start from 0 and go around like so until we get to 55, mark that point, and then the purple line would be drawn from there. And of course, because of the fact that we have it being due south, those two combined are going to make point C roughly there. Now there's a bit of give and take, so generally anywhere that is probably within this range here will be accepted as answers. So for example, if you were a degree or so out either way with this and you drew something like any of these, you're probably going to get the marks. As long as you're close to 55 degrees, you'll be okay. Oh, I deleted the yellow zone, but in any case I'll just leave C from there. Next part, the bearing of a point D from B, so that bearing is going to happen again at B, is 168 degrees. Find the bearing of B from D. So whenever you have this situation where you've got the bearing of one point to another, and then you're looking for the opposite bearing, as it were. Basically, opposite bearings are 180 degrees apart. So if you are going from one point to another and you're given a bearing, the opposite bearing will either be 180 degrees bigger than it or 180 degrees less than it. As long as your answer is between 0 to 360, that will be the accepted answer. So 168 here. Technically, you could take away 180 and you can add 180. Only one of those is going to give you an answer between 0 and 360, and that's the one you're going to want. So adding 180 gives us 348 degrees. Subtracting 180 gives us minus 18 degrees, and therefore the bearing that we're looking for is 348. Now it is worth noting that a bearing of 348 degrees, if I drew a north line here, is approximately going in this direction, where 348 would be that angle. Now technically, negative 18 would be 18 degrees anti-clockwise, so theoretically they do give you the correct angle in the correct direction, but a bearing must be 3 digits between 0 and 360. So although technically minus 18 degrees gives you the right angle, the only acceptable answer here for your bearing is 348. Gordon measures a length on the map as 6.3 centimeters, correct to 1 decimal place. Write down the lower bound for this length. So 6.3 correct to 1 decimal place is our number given. If we're looking for the lower bound, we firstly consider what number would have come before it that is also to 1 decimal place. That number would be 6.2, and the lower bound itself is going to be halfway between our number and the number before it. And halfway between these two numbers, if we add them and divide by 2, will give us 6.25 centimeters. Done.